So I'm really delighted that we're taking another quite distinct pivot in our programming, and we're now moving on to the Weller. It feels programmatically excellently timed, a bit like the end of the news, we go to the Weller. The end of the conversation stage, we will be going to the Weller. I'm really delighted that we have a really diverse panel with us here today, which is going to be excellently chaired by Matthew Chantry, who's the strategic lead for machine learning at the European Centre for Medium Range Weather Forecasts, to the stage. So I'm going to pass over to Matthew, who's going to introduce his panel.
Thank you very much, and sorry for the tongue tie of an organisation name that we have. Right, first of all, we have Rich Turner. Please, welcome. And next, Neil Hausmann. And now we have Caroline Bain. And Doug Parker. And last but certainly not least, Michael Baidu. Wonderful. So first I'm going to get our panelists to introduce themselves a little bit and understand what perspectives they're bringing to this panel. So Rich, please tell us a bit about yourself.
Thanks, Matt. I'm delighted to be here today. I am a professor of machine learning at the University of Cambridge, and I'm also the AI lead for weather prediction at the Alan Turing Institute. And my group builds AI models for prediction problems across the Earth system.
Wonderful. Thank you. Neil?
Hi, I'm Neil Hausmann. I'm a principal officer at the Gates Foundation, based in Seattle, Washington. And I work in the agricultural development group, mostly developing solutions for smallholder farmers in sub-Saharan Africa and South Asia.
Wonderful, thank you. Caroline?
I'm Caroline Bain. I'm from the Met Office. I'm the head of weather verification, weather impacts, and post-processing. But my long-term research interest is in African meteorology.
Wonderful. And Doug?
Hi, so I'm Doug Parker from the University of Leeds. I'm a professor of meteorology. For most of my career, I've worked on African meteorology. I've particularly worked in operational meteorology, so with the African weather services and universities in Africa, really looking at the challenge of making scientific forecasts useful for people in Africa.
Wonderful, thank you. Michael?
Yeah, I'm Michael Baidu. I'm a research fellow at the University of Leeds. I did my bachelor's degree at the Kwame Nkrumah University of Science and Technology in Ghana. I also work at the Ghana Meteorological Agency, and now, before coming to do my PhD at the University of Leeds in atmospheric science.
Wonderful. Thank you very much. And maybe to address sort of this point of the topic we're looking at specifically, we'll talk a bit about the transformation more broadly, but some of the questions are going to be focused on Africa in particular. And we did try to have an even more representative panel on this topic, but visa issues have meant that we've not been able to attain the perfect panel, but we still have a wonderful representation. So before we dive into the questions that I've set up from here, I just want to know we're going to later on in the second half, open up the floor to anyone who wants to ask this panel a question. So please do get thinking about the challenging or easy question, depending on how generous you feel for this group. But we're going to start with what is sort of just you come from a various domains. You may be not very knowledgeable about what's happening right now in this space. So we're going to get Michael to talk to us first of all about what is the current state of forecasting in Africa.
Sure, thanks so much. Like I mentioned, I work at the Ghana Meteorological Agency before coming to start my PhD. From my experience working at the Ghana Met Agency and also my experience working with other Met centers in Africa, I know that we do not run our own models, mainly because of computational costs and then also how much of power is required to run these models. And so we mainly rely on the global north for the forecast, the models, the outputs from the models that we use for our forecast. So we have the Met Office products, we have ECMWF model products, the NOAA from the US. So these are what we have mainly been using. We also, through a project in Ghana Meteorological Agency, we're running the WAF model at a 9-kilometer resolution, but we also had a challenge because sometimes there are power outages, And you know that when there's power outage, then it means that the model run stops, and then by the time we come, we do not have the products available. So that means that we still have to rely on the output from the global North models. And so, which then becomes a challenge because these models have mainly been developed for the mid-latitudes and not for tropical weather. And so that means that they are not able to simulate tropical storms accurately. And so, which is more reason why there has been the need to get models that run at a higher resolution over Africa that best suits African weather, which is a challenge because of the computational cost involved in running these models over most of these African countries, and which is the reason why taking advantage of AI models, which once the models have been trained, they are made available to forecasters and they are kind of easy for forecasters to work with it, becomes a good opportunity that we want to take advantage of.
Wonderful, thank you. Caroline, can you talk to us about how governmental and non-governmental organisations are supporting these efforts in Africa?
Yes, certainly. So the Met Office is part of a international cooperation called the World Meteorological Organization. So all national Met services are kind of part of this UN body. And through that cooperation, we share observations with lots of other national Met services across the world, including in Africa. And one of the things is that they share their observations with these global producing centres, such as the Met Office and the ECMWF. And in return, we also provide model data for the African centres. So we do provide very high resolution model data for most of kind of North Africa and into the sort of tropics. But I think that in general, one of the things that we're really excited about with the advent of AI is that there could be more resilience in some of these countries so they have the opportunity to own some of these models themselves rather than being too dependent on the kind of global producing centres that are generally in the global north.
Wonderful, thank you. And then, because we probably predominantly have an audience expert in AI, but less so in weather forecasting, Caroline, could you tell us a bit how sort of physics-based or the conventional way of doing weather forecasts works at the moment? Sure.
So we've been running numerical weather prediction for about 30 or 40 years. And the Met Office has actually been at the front of that for a very long time. Lewis Fry Richardson kind of had a very big vision of how to do numerical weather prediction back in the 1920s. The physics-based models are using effectively the most basic physics equations, the shallow water equations and things like that, to predict what's going to happen in the future based on fluid physics. And then we parameterize or kind of use smaller prediction models on a very small scale to represent processes that are happening below the grid scale. The AI models are taking a very different approach. They're not based on fundamental physics. They're very much based on the results that you're trying to simulate. And so there is a slight interest, and I know we'll get into it, but in terms of how you actually evaluate those AI models because of the approach that you're taking from the kind of bottom up, if you like.
Wonderful, thank you. So it's been described a bit that we have sort of two slightly dual revolutions going on about AI and weather forecasting. Rich, could you talk to us a bit about maybe what we might dub the sort of first revolution?
Yeah, that's great. So I should emphasize it's been a tremendously exciting time to work in this space where, a field that was relatively static, making steady progress over 50, 60, 70 years every decade, but on a fairly slow timescale has suddenly been completely transformed by AI over the last 2 to 3 years. And there are incredible opportunities across the whole of Earth systems forecasting coming as a result. So let me just talk a little bit, as Matt said, about what the first stage of that revolution is, and maybe in a second we'll talk about, actually a second wave of AI approaches in this space. So to go back to Caroline's explanation, the current way numerical weather prediction works is in 3 separate stages. You need to understand those stages to figure out and understand how AI is having an impact. In the first stage, you take information collected around the globe from weather stations, boats, satellites, aeroplanes, buoys and seas, and so on and so forth, and you bring it all together and you estimate what's the current state of the atmosphere. And then the second stage starts. And the second stage involves running this big physical model forward to say how the atmosphere is going to develop over the weeks, days, hours ahead. And that makes you predictions everywhere in a relatively coarse way across the globe. And then there's a third stage, a post-processing stage, where you take those coarse grid cell measurements and you forecasts, and you say what's going to happen at a specific location. That's called post-processing. And the first AI revolution was focused on that second step, the forecasting step, the big physical model that runs with tiny grid cells across the globe. And what people did was they leveraged actually Matt's data, or Matt's organization's data, 40 years of incredibly high quality data, which providers like the European Centre for Medium Range Weather Forecasting have generously made available to the community. These are incredibly clean, beautiful data sets with hundreds of variables present in them that have a real triumph of engineering and science. It's not like data in other parts of machine learning, which has privacy concerns attached to it or missing data. It's incredibly clean, noise-free. And what the machine learners did was say, hey, this is data ready, this place for machine learning. Many fields aren't quite sort of machine learning ready, but this field definitely was. And machine learners did what machine learners do. They went down their toolkit and say, hey, we've got these great things called large language models with transformers in them. And the transformers sort of take the previous set of words in a sentence and predict the next word. Well, could we use the same thing on weather? Could we take the previous state of the atmosphere and forecast the next state of the atmosphere and just train it in pretty much the same way? And so they actually took a thing called a vision transformer to do this, so a particular variant of a ChatGPT-like thing, a transformer that has been ported over to computer vision. And you treat the numerical data like you would an image, and you use that to forecast the next state of the atmosphere. And when they train that, and the first revolution has been progressively improving the models trained like that, you can actually do as well as, if not slightly better than, the best numerical systems. But this doesn't take a supercomputer to run that step. It takes a few GPUs. Training's quite expensive, but once you've trained it, you can literally run it on maybe 1 GPU or 4 GPUs. And so you're replacing the work of a large team that has to develop these things over many years and maintain them, and a supercomputer which is very expensive, and reducing those costs by 1,000 or 10,000 times, which opens up a vista of new opportunities. Maybe we'll leave it there for the minute.
Yeah, wonderful. Yes, thank you, Rich. But so that's only the first one. I think we should talk about the fact that that first one is still very much ongoing. This is not a final stage, but maybe an example of this is at ECMWF we've recently operationalized. We might come back to that word and really what it means, but a first AI model daily making forecasts out. This is called the AIFS, and allowing the world to sort of understand how these AI-based models can compare to the physics-based models. But already, even though that first revolution is ongoing, the second one has started to become. So, Rich, can you talk to us a bit about what's different in the second one?
Yeah, so maybe we go back to these 3 steps. So remember we said the first sort of rabbit in the headlights of deep learning was the second step, the forecasting step. But perhaps the thing which is overlooked by many of the papers, and we're talking about papers from Google and Huawei who have developed systems to do this, have overlooked, is the fact that the first step of numerical weather forecasting, where you integrate all of the observational measurements from satellites and weather balloons and boats, etc., into the model, which of course is crucial, that step is just as expensive as the forecasting step. So if you've got your AI model that can do the forecasting step, you still need your supercomputer and your big team and your huge costs to do that first step for you. And that's what Matt's team has done at ECMWF to get these things running. So the second step, and that's something that's been very close to my heart, is to try and do everything together. So a single machine learning model that cuts across all 3 of those stages, that's trained end to end to take raw observational measurements forward and produce forecasts. And if you can do that, then you can run these things on GPUs or desktop computers. If you're maybe a country in Africa that can't support one of these teams, you can run it as a company, and you could optimize it, for instance, for your own personal weather forecasts as well. It opens up a whole vista of opportunities. Notwithstanding the fact that you can train the whole thing end to end, and you can train it on your own personalized problem in your own region of the globe to do what you care about. So I think this opens up many possibilities that just weren't open to us before, and in particular in the present context of Africa, I think it's tremendously exciting.
Do you think the data is as AI ready in this second revolution we're going on?
So that's a great question. So whereas these first data sets, as I said, were really clean and well curated, so when we built this prototype system, which is called Aardvark, that's a paper that will come out in Nature actually on Thursday. It took us, and I should say us, it was really a student, Anna Allen. It took her 2 years basically to collect the data. So this is distributed in multiple places throughout the world. She made friends with many people to get access to this data. It's much harder to come by, and you need different types of machine learning to handle this. It's quite a complicated data to handle because you get missing data. It's not nicely on a grid. But once you can port these transformer-based systems over to that, then you have something that can really push the state of the art. And just to emphasize what the possibilities here are, on accuracy, people have estimated that you can get 2 to 3 days extra improvement in the efficacy of your forecast. So your forecasts at 3 days will be as good as your previous forecast at 1 day ahead if you can use these new techniques. So I think fantastic opportunities here.
Connecting back to our panel topic, what do you think are the main implications for Africa?
Yeah, okay, so main implications for Africa. I think, first off, Michael was talking about whether you need a large team to support this. Now we can cut things down and support these things with small teams. We need supercomputers to generate training data still, but once we've trained off it, we can then fine-tune in a second stage to local problems of interest. So that second phase of training actually can actually be really cheap. And in the Aardvark paper, we show you only maybe need 3 or 4 or maybe 10 hours of training on GPUs to do that second stage. So if you're a small business or a country in Africa, or you're playing around with weather for fun, you can really do that on a desktop computer. Third thing I should say is there's this question about whether the physical modeling approach really is the right approach for Africa, especially as you go out to longer timescales, like sub-seasonal timescales that we need for agriculture. And their statistical models have often been the best way forward because of the inaccuracies in our sort of northern forecasting systems in Africa, and also due to fundamental meteorological constraints in that space. It's a more chaotic system driven by convection and things like that. And so by training things directly end to end, you cut to the chase and you have the opportunity to actually go beyond the accuracy of the current sort of physical modeling systems.
Wonderful, thanks. Doug, can you talk to us about how you think AI will possibly change the landscape for forecasting in Africa?
Yeah, I think, as somebody already said, it's a massive transformation at the moment. The opportunities are tremendous at the moment. Over the past couple of years, the whole landscape of opportunities has really evolved. And the first thing to say is just following on from what Rich was saying there, that there's a real opportunity to improve the accuracy of information, the accuracy of forecasts for users. And many people in Africa are, their livelihoods are very sensitive to the daily weather. So there's a real opportunity to we don't quite know, what the limits on that accuracy are. So we know there are some fundamental chaotic limits on how far you can predict the future in our chaotic world. But certainly we are seeing this new generation of models, pushing the boundaries and pushing beyond what we can currently do with much cheaper models. So we do, expect that to continue to improve to some limit. But I think more importantly, because we can really localize and train these models on the challenge, the specific problem in Africa, rather than training with a global focus or even a European focus, we can focus on Africa. Then we have, we can focus our attention in improving for this specific region rather than optimizing for the whole globe. So for those reasons, I expect the quality of the information to be increasing. We're seeing that already, of course, but then again, the other changes are sort of more operational, and I think that's also where we have a real opportunity now. The first is that we would really hope to be overcoming some of the challenges that Michael introduced at the beginning, in the sense that smaller teams, less specialized teams within Africa, with smaller computers, can actually be creating and delivering and innovating the forecasts themselves, being close to their users, their user communities, and really kind of designing and training solutions for, locally, in Africa, for Africa. And I think that, that change is really fundamental in it. And at the moment, we're sort of struggling with the fact that information is coming from the global north. There's a power imbalance, and it's not always configured in the way people want it, and it's hard to make use of. So actually shifting that center of gravity to Africa will be enormous change. But then I think the third and really another transformative change is that this revolution in AI forecasting has really been driven by the private sector, which is, throughout the evolution of weather forecasting to date, it's all come through government agencies. And so again, nobody quite knows where this will go. The private sector has been very active in terms of the global corporates, initially driving this with enormous computational power, but also now small, SMEs, typically in the global north, realizing that they can produce products and make money from those and sell them. So this is just another big shift. I don't present that as good or bad. I just say that this is the state of how things are changing, and I think the next 2 or 3 years we're going to really see the implications of that.
Thank you very much, Caroline. Can you talk to us a bit more about this sort of the role of public and private in this space, as
sure,
we see the two being brought together?
I'm the British government person on the panel, so I think the importance. So the thing I would say is that I'm not anti-private sector. I think that actually the private sector is doing some really exciting things in the AI space, and what I'm seeing at the moment is that there is an appetite to act responsibly, especially in Africa, where they are starting. The forecasting is starting from quite a low level. There is not that much, information available to the public at the moment. But there are African institutions and there are existing Met services in Africa. And those Met services, actually, some of them are, well, actually all of the ones that I've visited are staffed by extremely dedicated people who are really excited about the potential to embrace and extend their scientific work and their forecasting capabilities. So one of the things that certainly the Met Office is really trying to encourage is for private sector to work with the existing African institutions rather than bypass them, so that we end up with kind of public-private partnerships rather than a private company coming in and usurping what should be the authority of the sovereign states that are existing. So I think that's where we're at an interesting stage where actually there's a huge amount of power in these private companies, and then it's up to them very much about how they use that power. And I'm very excited that there are private companies who are really asking us the questions, how do we do this responsibly? How do we do this for the global good? How do we make sure that we don't bypass local institutions? And I'm really trying to encourage those conversations to happen, which is why Neil's here.
Wonderful, thank you. What about Neil? You represent a different group, sort of what are your thoughts on this public-private space? Or maybe, in fact, more broadly on the changing landscape that we have?
And I think part of the way that we approach it, the Gates Foundation, is to ensure that as these new models become available, right? So I was visiting a small startup in California. They had a closet where they were training a global model. And so just the pace of change is so rapid. And those models are becoming available, right? There's APIs now for some of these new models. And they're global models. They haven't necessarily been tested anywhere other than with the kind of standard scientific type metrics. And so it's really hard for a Met agency to know whether it makes sense to use these. And in many cases, there's no reason to do so. Although now there's a new forecast and it's just freely available from API. And so one of our main focus areas is around benchmarking or evaluation. So we know and can work with Met departments to know whether they should adopt these, how they should adopt them, how they can go from a global model and do kind of fine tuning or local debiasing to actually make a model that's performant in their country, how to then operationalize that, make that with, to go from this API call to be able to downscale, localize, and then generate effective daily forecasts for their country. And often an exciting opportunities. They could do it all on premises in their own location without, with a relatively low infrastructure.
Wonderful, thank you. So we've heard about the excitement, sort of now about what we need to do. Sort of, Michael, can you talk to us about what you think's needed to sort of fully exploit these opportunities for AI forecasting in Africa?
Yeah, I think to fully exploit these opportunities, it's very important that forecasters in Africa are training how to use the AI models that are made available to them, because then they are able to ensure that it's really being used and not just end there, but also to have a collaboration with the universities in Africa so that we train new scientists who are equipped with knowledge and skill in developing AI algorithms that are best suited for Africa. So having that kind of collaboration, I mean, there are a couple of projects that I'm on in collaboration with my former university in KUST in Ghana. And what we are doing is to currently training a number of master students in how to develop an AI model for nowcasting. And so by doing this, we create a team of raising a new generation of African scientists who are equipped with a skill in developing and evaluating AI models, which then become very useful for the sustainability of this, because then they're able to collaborate best with the Ghana Meteorological Agency. Whenever the forecasters have a challenge with the model, they are able to fall on the universities, the scientists at the universities, to help them out, and so that there's kind of that chain going on, and there's that sustainability, so which is a very useful way of ensuring that this is sustained.
Great. What about on the infrastructure side? Is that something where?
Yeah, so with the infrastructure side, I mean, with the availability of the, making sure that we have improved internet facilities so that these models that are made available to forecasters are able to use them in real time, and also to be able to ensure that we have enough storage for data so that we're able to train the models with the data, because most of these models, we need a satellite data to be able to, for nowcasting, for instance, we need satellite data in real time. And so having enough storage, computational storage to store this data, which can be used to train this model, is very, very important. And as well as also improving the collection of observational data. So currently, apart from the synoptic stations that provide data to the for the global forecasting centers, we also have we also have data that's also from the automatic weather stations, and we need to ensure that these automatic weather stations are working operationally. Sometimes the challenges, some of them, after the projects, they run out of batteries, and then you don't see them working operationally. So to ensure that this data inflow is constant, we need to ensure that these automatic weather stations are really being maintained, and then that helps to ensure that we have data to train the models.
Great, thank you. Neil, your thoughts on maximizing exploitation of AI forecasting?
Yeah, and so maybe I'll start bringing this kind of a step down towards kind of impacts of climate change in African agriculture. So one of the opportunities, right, so these models and this landscape is evolving so quickly from the AI standpoint, it's evolving almost as fast as climate change is impacting farmers. And so one example in East Africa, there used to be 2 rainy seasons. There was a short rain season and a long rainy season. And then with climate change, the short rain season has started late, been very small, and very intermittent. And it's caused a lot of farmers to decide to not plant at all. So you can just imagine if half your paychecks didn't come one year versus the other. And it has huge impacts on farmers' lives. And farmers make up, up to 70% of population. And so climate change is having extreme impacts. And because of this uncertainty, people are often moving towards conservative actions just to make sure. And so this leads to people not planting at all. And so those are opportunities I see for these new models, so specifically in this subseasonal or 3-month time step, where farmers will have enough time, energy, resources to actually make decisions. Should I plant? What crop should I plant? When should I plant? With enough foresight to be able to get all of the pieces together to do so. And so that's an area that we're specifically focused on, is this start of the rainy season and providing farmers with determining when to plant as a kind of a task. And then, as I mentioned before, the benchmarking efforts. We've also started to move away from these scientific kind of meteorological benchmarking approaches. that work very well for numerical weather prediction, but trying to see how we can think about it differently from an AI perspective and specifically be task specific. So if you wanted to know when to best plant, one, what model should you train, but also how would you know when that rainy season will start? And the challenge there is this: you only have one data point a year. It starts on a certain date. So you have very, very sparse data for validation there. And so we're also looking to Earth observation and these geospatial foundation models to help us see are there other data that will determine, for example, when all of a sudden the world became green. When it rains, all the plants grow, the crops grow. And so there's a lot of signal there that could be used for benchmarking that have never been used before, couldn't have been used for numerical weather prediction, but could be integrated into these end-to-end systems in a really interesting way.
Great. And what about getting this data sort of AI ready? How do we?
Well, so I would say, and kind of follows on my previous point, really interested in new and alternative data sources. So for example, data that you can derive from cell phone towers, from cell phones themselves. So looking to data types that are scaled, are available in Africa, because of course, as Michael mentioned, there's a lot of challenges with automatic weather stations not reporting. In some regions, up to 80% of the infrastructure isn't reporting up to spec. And so really need to look for, to drive these models to work for Africa rapidly, we need to think really differently about the data types. And excitingly, AI is very omnivorous in its data usage. So exploring that very actively.
Wonderful, thanks. Doug, did you want to add anything on this maximizing exploitation?
Yeah, I think there's a key point here that the system is not somewhat broken at the moment. As you say, 80% of stations not reporting is probably optimistic. But there's a possibility in future actually we make a much better link between the data collection and the production of the product. So currently data is sort of sent away out of the country to the global north where it's processed and then a product comes back. And the product is not necessarily well configured for what's needed. It's not well used, and so the loop is not well closed. So if, as we can imagine, we may have local optimized models running locally with data that's being brought in locally, both for training locally, but also for the daily operation. We may see much better drivers to maintain the quality of the data collection locally.
Wonderful, thank you. So, Rich has given us a great insight into that these systems have rapidly come from nothing into now being systems that are starting to run on a daily basis. But next we want to talk about whether and how we get people using them. So, Caroline, can you talk about the challenging question of how we might get people to start building trust in AI forecasting systems?
Sure. So this is something that actually is quite equalizing worldwide, because it is not just Africa that is going through looking at the adoption of AI. It is everywhere, including the UK, including Europe. All countries are currently looking at whether AI is able to complement our current weather forecasting capabilities or even transform them completely. So it's a question that all countries are asking themselves, and we are talking to other national Met services about how to do this well. At the end of the day, what national Met services do is not just produce data, they are creating advice or bespoke products for different sectors. And the sectors that Met Office serve are things like industry, defence, the public, energy, aviation. So there's lots of different sectors, and they all have subtly different things that they care about and that looks good, like what good looks like. So evaluation, verification is a very important subject actually when it comes to AI, especially because AI will train based on a result. So you can get outstanding results sometimes because essentially you're mimicking what is a statistical pattern or something that is your AI is optimizing to what you're trying to create it for. But that does also mean that you have to be quite careful because you really need to know what question you want it to answer while you're designing it. And one of the things that's very difficult about that is if you don't have the observations to verify in the first place, actually then saying, create a result that will do a forecast of precipitation over Africa, let's say. Well, if you don't have precipitation over Africa in the first place to say, and was your prediction good or not, the truth is it's quite difficult to then say whether that was a good prediction. So one of the things that's challenging, especially in data sparse areas, is actually understanding whether the AI is doing a good job or not. And that is one of the grandest challenges we have in these data sparse regions such as Africa. The good news, or at least the kind of positive note on that, is that there are remotely sensed observations, and we do actually also have a lot of observations in Africa. There are automatic weather stations, and some of them go back for a very long period as well. But also, ultimately, we have users. And one of the things that I would hope that AI, and if we are getting AI out to users, is that there's a user feedback loop as well, so that users tell you whether you're creating a good forecast or not. I mean, that's something we do in the UK, and we rely on people telling us whether we've done a terrible forecast, actually. It's helpful to us. But, it's the same thing in any country, in Africa especially, is that if you do create bad forecasts, you find out pretty quickly, and people do tell you about it. So it's the objective as well as the subjective that is useful for understanding and really kind of pushing those AI models to the next level.
Wonderful, thank you. Yes, I think this direct feedback is something that's been driving us a lot at the European Centre for Medium Range Forecasts, getting data out as quickly as possible to hopefully get mostly positive feedback, but also actually the negative feedback is even more constructive as we look to improve these systems. Michael, your thoughts on how we build trust in these systems?
Yeah, to build trust in these systems, from my experience, at the time I was working with the Ghana Meteorological Agency, I noticed that the first challenge is to get the public to trust the forecasts that are being produced, because the first, as I mentioned earlier, with the challenges associated with predicting the tropical storms, normally with the public, if there's a forecast that there's going to be rain in, let's say, the city of Kumasi, and the person lives in one part of the city, and the storm actually hits the city, but the person's location within the city did not experience the storm, then to him, the storm didn't come. And so to them, the forecast is false. And so to be able to get these people to trust the forecast, we need to ensure that there's evaluation of the forecast, which currently through the initiatives of projects like the SWIFT project, we are beginning to have GMET, the Ghana Meteorological Agency, beginning to do proper evaluation of the forecast and making those outputs available to the public through their social media channels. By doing this, the people were able to really see the forecast and know that, of course, even though I didn't see the rain, I'd see that the forecast was 80% accurate and stuff like that, which helped to build the trust of the people. And also co-production, so getting stakeholders directly involved in the whole process, make them really appreciate the forecast and also get to know that it's being tailored to their needs. So then it makes them really begin to trust it and also help to support its maintenance as well.
Wonderful. Thank you so much. Right. Now I hope you've all got some good questions, because we're going to open the floor, sort of possibly raise the lights. I think we have some wonderful assistants in the room. So if anyone thinks that we've missed a trick, not asked a particular question, we'd love to hear from you. That goes for those in the room, but also online. I think they've already started to become a few questions here. So maybe I'll start with one online. Question is asking how the increasing integration of AI in forecasts could affect the employment prospects of young scientists. Does anyone, Caroline?
I feel super excited about it, especially in Africa. There's, I think 60% of the world's youth is 60% of people are under the age of 25 in Africa or something like this. So in terms of the prospect of talent, actually I think there's some really exciting potential for more AI scientists, more computer scientists, more mathematicians, kind of being based in that region. In terms of job prospects in general, I tell my team, I'm like, we're not going to finish science. There's not we've completed it now. There's still going to be plenty of jobs in the future. And I'd hope that what AI is doing is taking away the kind of boring bits that actually humans don't really excel at. And we're doing the more nuanced things that do require kind of creative thinking power. So I feel massively optimistic that actually there's a lot of potential for very exciting and different jobs in the future. They're not going to be the same as the ones that we've got today, but that will favour people who are really able to adapt in this kind of new exciting world that we have.
Thank you. Any fellow panelists want to add to that?
I'll have just a quick comment, is that in many places in Africa, forecasts are not reliable. And so if you were able to have reliable forecasts, new sectors can open up, for example, in insurance or in generating business plans from forecasts, to helping provide advisory to farmers through tailoring the forecast to their specific needs. So I think there's a lot of opportunity for growth as kind of the rising tide raises all boats, as you get forecasts that are really operational and usable.
Thank you, Neil. Questions in the room? No, I don't see any moment, but that's okay. We can keep with the... Oh, sorry. Yes. Thank you. Sorry, the lights are quite bright, so I'm not shunning you.
AI is famously bad at extrapolation, particularly when you have very little data to train it on to begin with. In regions with very poor data coverage historically, like Africa, how much can we trust AI models as we extrapolate forward with climate change?
Good question. Rich, do you want to?
Yeah, I have a few things to say on this, though maybe not specifically for Africa as a region, but more generally. So I think this question was like front and central in everyone's minds when they were training these models to start with. It's like, okay, the average performance of one of these systems is really, really good, but we don't need it to perform well in the average case. We need it to perform well in these extreme cases. And as you say, machine learning has like a poor track record in that case. If there isn't much data, then you're asking it to generalize. And I think it's fair to say it'd be interesting to get Matt's take on this and Caroline's. But for me, they've exceeded my wildest expectations in terms of how good the extrapolation is. So this, you should take that with a grain of salt. This evaluation is still ongoing, and it's by no means comprehensive at the moment. But I'll tell you a story from our work at Microsoft where we looked at tropical cyclone forecasting. So tropical cyclones, obviously very extreme weather phenomena. Aren't many tropical cyclones in the data that we're training off of for the last 40 years, comparatively speaking, very extreme events. And we built like a foundation model at Microsoft, which we then fine-tuned to lots of different tasks. And one of the tasks we looked at was generating tracks for tropical cyclones. And at least in that case, the system surprisingly are outperforming not just the best operational numerical systems, but actually outperforming the teams that then provide forecasts based on those operational systems. So this is not going to happen across all of these different types of phenomena, but people have gone through fairly systematically, and it is true, you can see in the tails like extreme cold, extreme heat, these things falling apart a little bit, but it's not catastrophic at the moment. Yes, there needs to be lots of tests, and I think one answer to this is to look at transfer learning. So you transfer learn from data-rich regions into data-poor regions currently. I think active learning to tell us where to put small numbers of additional sensors is really helpful. And I think leveraging remote sensing satellite data, particularly if you can learn the relationship between actual station data and remote sensing data in different parts of the world and then transfer learn across, so where you still have access to that remote sensing. All these things can help. So the machine learning is not going to provide a complete answer, but you've got a toolbox of stuff that you can start to do there, which is probably putting us in a lot better situation we were in than in the first place. It's a great question, though.
Yeah, I think it's great. I think I'd just add that, it's why I think we need at the moment to have these sort of machine learning systems coexist with physics systems to understand the strengths and weaknesses. We were doing that for the whole of last year. We had systems running in parallel, and it was really interesting to look at these extreme cases. So I think the one I invoke a lot, sadly, it's not in Africa, so not quite as appropriate for this panel, but there was some, in the spring of last year, there was some unprecedented rainfall in UAE and the surrounding region that was well outside the climatology thing. We're very good at building climatological data sets for the region, therefore understanding what is the maximum precipitation ever observed. Despite this, The machine learning models did an excellent job of predicting that it would be well outside the distribution. They still underestimated the maximum amount, but so did physical models. I think the way I would argue that sort of we understand that is, while that was extreme for that region of the world, there are other parts of the world that have seen more extreme rainfall amounts. And so the things that have perhaps not been tested yet for these AI systems is when we're at a truly global, unprecedented value, something that's never been seen anywhere in space and time. Whereas I think a more common, but still very dramatic impact will be things that are extreme and novel for a specific location, but fall slightly further into the distribution for somewhere else. I don't know if anyone else wants to add to that.
Well, just to reinforce that last point, I mean, we've known, since the 1960s, really, the discovery of chaos as a process, that actually the time scale for predicting things increases, the spatial scale increases with time. So when you're looking at, say, a 1 or 2 day forecast, it's really the global information that matters. When it comes down to sort of daily, very short range, 6-hour forecasting, then you need local data for sure.
Wonderful. I think we have time for one more question, if anyone has a burning one to ask.
Just one hand.
Yes, thank you.
Hi. My question is basically particularly to a region, the Lake Chad region, right? So with these AI models coming out with the data that we need, right, which that region has been greatly impacted, is a lake that is shared with 3 different countries, and because of the resource is dwindling, is affecting farmers, herders, and their clashes. So where you have different governments that are sharing the same resource, how do we ensure who benefits more, who controls the use of this model in a government setting, especially in somewhere like Lake Chad, where you have different countries using the same resources and all? That's the first question. Then the second question is, in terms of AI models, they sound really cool and fantastic in Africa, right? But the end users, who are the farmers and the local people, how do we ensure that they can actually make use of this data to actually build a livelihood around it and they can trust it?
You want to ask Caroline? You want to?
So, firstly, on the question around sovereignty, I think I will always defend the country's right to be able to provide their own weather information, but that doesn't mean that cuts off cooperation between countries. And there are cross-governmental institutions such as ACMAD, which we were hoping to get some representation of here, which work across different countries, especially in West Africa. On the question that you've raised that's really important, which is actually, this all sounds really cool, but what's the impact on farmers? That's an excellent question. And although we want to present a really optimistic picture right now, we are at a very early stage within this. Operational weather forecasting, even in the UK, has not turned to AI yet. We haven't operationalised it, even in our own systems. So this isn't something that's available right now to national Met services in Africa. We hope that it will be in the future. But the prediction element is just the first step. There are then multiple other steps that have to take place after that about how you turn that prediction data into something that can be a product that is then able to be consumed by the farmers, by the users that are actually going to be making decisions based on that. And that's where co-production comes in. So it becomes really, really important that it's not just a kind of data product that nobody actually can use. It becomes something that can be used for decision making. So whilst prediction's really exciting and really important, it depends on that kind of actually getting it into use, the post-processing, the product creation, the user experience, to make sure that it actually sees the light of day and ends up in a decision being made by a farmer.
And I'll just give one example of that, where our first project actually in this space was working primarily with the Kenya Agricultural Livestock Research Organization, CALRO, which is a key farmer support part of the Kenyan government, and working with them to take their previous systems, which had already been sending kind of regional level support for farmers, specifically on when to plant their crops, and help them tailor those, using higher resolution weather forecasts, to tailor those recommendations at the farm level, so that you get more personalized recommendations that can take into account, for example, differences in elevation. And so with that program, we started, I think, 4 years ago, and working very closely with CalRO, and CalRO was the one sending out these advisories via SMS texts. We're now reaching 7 million farmers in Kenya, or they're reaching 7 million farmers in Kenya with new information. So I think that's a major, quote unquote, route to market is through these national agricultural research teams who already have the writ and responsibility to provide best information for farmers.
Thank you. Michael?
Yeah, just a quick one to add. I think, from the Swift projects, we have the app called Faster, which is, the aim of Faster is to get forecast information directly available to the individual local farmers and local fishermen, which Dr. Parker is leading that project. I think you want to talk a little bit about Faster?
Oh, well, yes, thank you. It's an example of how, we can use modern technology. More people have cell phones. It's not the only solution because cell phone usage remains somewhat limited, but it's just to say that there are more and more ways now to actually get information directly to people. And I think what's going to be most important for this is encouraging the African ownership of that kind of solution. So people close to their communities can start to create those products and improve them for their clients.
Wonderful. Thank you. Well, I'm sure we could talk about this all day, but sadly our time has come to an end. So if you could please join me in thanking our wonderful panel.